just reflecting on yesterday's lesson, and it did, I guess, appear to me that you guys didn't quite connect with the explanation I was giving of Dijkstra's algorithm yesterday. So I'm thinking about a different way potentially to explain it. It's important that you understand, the process of it, even if you might think it's a little bit unnecessary, particularly with the type of networks that we are using. And sometimes you're right, you can quickly do a shortest path decision without actually having to go through the whole Dijkstra's algorithm. I get that, but in terms of understanding how it works, it is important that you know that. So I want to just, I guess, come at it from a slightly different point. We're going to get my example network up. So, okay, here we go. Right, so here's our example network here, and we want to find the shortest path from A to G. Okay, the shortest path from A to G. And so Dijkstra's algorithm says that we start with A, and we keep adding an edge to make the shortest path. But I guess a sort of different way to explain that. A different way that we talked about yesterday is to say, what is the closest vertex currently to A, or the shortest, cheapest, whatever of those terms we use. What is the cheapest path to a vertex? And we make that choice. In this case, we can see that is from A to B. That's the shortest path at the moment. So AB equals 5. That is the shortest path we've got from A to another vertex. Okay, so Dijkstra's algorithm says, okay, now, if I was to go to a new vertex from there, okay, either again straight from A somewhere or from B somewhere else, what is the next closest vertex from A? What is the next closest vertex from A by adding an edge somewhere? So I can go D, which is 11. So ABD is 11. Or I've got ABE, which is 12. I've got ACE, which is 11. And I've got sorry, that's a mistake. Not getting to C yet. So AC, which is 7. And that's it. Okay? They are the next 3 vertices that are, I guess, by adding one more edge, I could now get from A to that vertex. So what is the cheapest one? What's the next closest one? It's this C here. So AC, we add that one. Okay? Now, what is the next closest vertex? And so now I've got, again, my ABD, 11, I've got ABE, which is 12, what did I say? 12, yes. AB is 12, that's right. Now I can go ACE, which is also 11, or I can go ACF, which is 11. Okay, so they're the next closest vertices from A. Adding one edge, what's the next closest one? I can choose either of those. Okay, I can choose any one of those that I want to.
Are we going to D or G?
G. Yep. Okay. Now, at this point here, using Dijkstra's algorithm, it says it doesn't matter which one you choose, and I just go through the steps again. If you want to be, I guess, clever about it, knowing that we need to go to G, you kind of almost work backwards. What is the cheapest path from 1 back to G? I can see this 10 is the cheapest of all the edges that attach to G. You understand what I'm saying with that? And so let's go to D here. Let's choose that one. A, B, D, because I could choose any of these 3. They're all 11, but knowing that I want to get to G, I'll choose that one next. Let's say I'm going to add that one. Right, so I've now added that one in. And now what is my next cheapest ones? I could go through that, but I've now got a point where I can say, I can see that for my question, which is the shortest path to G, I can now just go straight to that, and I can say A, B, D, G is 21. Okay, that's how, I guess, a combination of using Dijkstra's, but to answer a particular question.
So you don't need A to C? Like if...
No, but it's at that point, but I still, having not actually done all the different versions, I wasn't quite sure, maybe that was going to be the cheapest way to get there. Maybe that 7, 4, 13 was going to be better, but it's not, okay? So if that was 10 out there, that would have been just as quick as ADG. So ABDG and ACFG actually would have been the same. That's why you do that, just until you get to the point where I can say, oh, I can see that's not going to be. Okay? Getting to there costs the same as getting to there, and costs the same as getting to there. And so if all of those three cost the same, which is the cheapest one from that point to G, well, it's this top one, I'm going to use that one. Does that kind of make sense a bit more of Dijkstra's algorithm? We're saying what is the next, how can I get to the next vertex by adding one edge in the cheapest possible way? The next closest vertex. Does that help in the understanding of Dijkstra's? In the end, as we say, we need to go, we generally are asking what is the shortest path from one vertex to one vertex. Sometimes you will get a question that asks you, what is the shortest path from this vertex to 3 different ones, therefore which is the shortest path of all? So you need to go through and do a number of them. Okay? Normally they'll just be from one vertex to one vertex.